Okay, ladies and gentlemen, another problem that commonly comes up in chemistry that gives students a lot of difficulty is the problem of finding a percent. Now, there's lots of different ways that you can find a percent. You can find percent of different things. And what throws people off too often is they're trying to memorize a formula for everything that they're finding a percentage of instead of understanding what a percentage is. So let's just go back and let's talk about the word for a second. Percent. If you look at that word, it literally means out of 100. So remember, cent is 100. There are 100 years in a century, 100 centimeters in a meter, 100 cents in a dollar. The Roman numeral C means 100. Cent is 100. So per cent means out of 100. A lot of times when people teach this, they'll say the way to set this up is to say that the part over the whole is equal to the percentage over 100. So they're setting it up as a proportion. I think this is a good general way to set this up. This is the way that I'm going to show you. There are other methods for solving percentage problems as well. One thing I do want to emphasize here, though, is that the part does not always have to be smaller than the whole. So sometimes that's a little bit confusing because you would expect the part to be less than the whole. I will try to explain to you what we mean by the part and the whole by looking at some examples. And I want to look at some examples that come up in chemistry. So two different percentages that you very commonly find in chemistry are percent yield and percent error. And like I said, a lot of teachers teach this by having the student just memorize a formula, plug into a formula, and solve. But I think if you understand what a percentage is, you shouldn't need to memorize a formula. The formula should make sense. Let me give you some numbers with this, and with these numbers that I give you, you'll be able to find both of these. And I'll walk you through and show you how to do it. So let's say that a student is going to perform an experiment, and he calculates before he does the experiment that he should get 250 grams of product. This is what he expects to get. So you can call this the expected value. Or more commonly in chemistry, we call it the theoretical yield. How much we expect to get in theory. Let's say that he goes through and he does this experiment, and he actually ends up getting 240 grams of the product. So this is how much he actually got. I'm going to call that the actual yield. Some people also call this the experimental yield. Now, based on these numbers, I should be able to find these percentages. So before we do that, let's think about what each one is asking for. This one wants the percent yield. So percent means out of 100, and yield means what you got. So the part that we're looking for is going to be the yield, what we got. Now when we did the experiment, how much did we get? Well, we got 240 grams. That's how much the experiment yielded. So the part in this case is 240. Well, what is the whole? The whole is what we expect to get. So we expected to get 250 grams. Notice, if we get less than we expected, our percent yield is going to be less than 100. If we got more than we expected, then the part would be bigger than the whole, and our percent yield would be more than 100%. So now we have the part over the whole is equal to the percent over 100. Notice here, the units cancel. Percent is really a unitless number. And here, the math is easy to do without a calculator. Both of those divide by 10, so it simplifies. We can multiply by 100. 100 divided by 25 is 4. 4 times 24 is 96. So we got 96% yield. Now, in chemistry, very often students confuse percent yield and percent error. And the reason they do is they're just memorizing a formula. Let's think, though, about what this means. Here to find the percent yield, the part was the yield. But here at percent error, the part is going to be the error. So let's think about what our error was in this experiment. We expected to get 250 grams, and we only got 240. How much were we off from what we expected? And I think that you can see that we're off by 10 grams. And we got that by subtracting. Now, we always want that number to come out positive, so I always just say take the bigger one minus the small one. Some people will say take the absolute value. Don't think of it as memorizing a formula. Just think how much were you off? Well, we were off 10 grams, so this is our error. So now let's say I want to find the percent error. It's still going to be the part over the whole. But instead of the part being the yield, the part is going to be the error. So now we have 10 grams that we were off. Out of the whole thing. Well, the whole thing is what we expected. 10 over 250 equals the percent over 100. Notice again it's unitless. The units cancel. Again, the numbers are easy. These both divide by 10. And if we multiply by 100, 100 over 25 is 4. 4 times 1 is 4. We are off by 4%. And that should make sense. If we got 96% of what we expected, that means we were off by 4%. So instead of trying to memorize formulas such as the actual yield over the experimental yield times 100, or the actual yield minus the experimental yield times 100, just think of it as a percentage. It's the part over the whole. The part is what you're looking for. So if we're doing percent yield, the part is the yield. If we're doing percent error, the part is the error. And we always want to compare it to the whole